Factor theorem. Consider a polynomial p of x with the degree n is greater than or equal to 1. Degree of p of x is greater than or equal to 1. Degree of p of x is greater than or equal to 1. Okay. That means the polynomial's degree starts from 1. Okay. And we are dividing the polynomial by x minus a. It turns out that the divisor x minus a is giving the remainder 0. So, when a divisor does its job perfectly, cleanly, it will get a promotion like factor. Okay, a divisor divides completely, divides cleanly with no residue, no remainder. Then it is called as, promoted as factor. Okay, so if x minus a is a factor, then f of a is equal to 0. Which means what? A is the 0 of the polynomial. Okay. Suppose we know the divisor, we know the 0. We need to find the factor. How we will find out? That is given the second part. Suppose if f of a is equal to 0, then x minus a is a factor. Understood or not? This comes from the previous theorem called remainder theorem. What is remainder theorem? While dividing by the factor x minus a, the remainder is given by f of a. If that f of a becomes 0, we can say x minus a is a factor. Says factor theorem. And if x minus a is a factor, then we can say f of a is 0. Simply, initially I gave you an example. What is that example? Can you recollect? X square plus 3x plus 2. Remember? We know that initially p of minus 1 is equal to 0. Previously worked out. You remember, right? P of minus 1 is equal to 0. Then we can say x minus of minus 1 is a factor of this polynomial, because we still don't know the other 0. To find this factor may help. Okay. Like suppose if we know that x plus 2 is factor of this polynomial, if we know that in prior f plus 2 is polynomial, then what we can say? Which one will become 0? This f of minus 2 is equal to 0. That means minus 2 is 0 of the polynomial. That is what this factor theorem says.